Guys, today we're going to talk about the difference between frequency displays and relative frequency displays. And as far as making the graph goes and actually physically graphing it, you're not going to see a whole lot of difference. It's the big difference is going to come in the data you choose to display and in the way you choose to display that data. So we've been talking a lot about frequency displays. Frequency displays measure and display just raw data. If I surveyed um, 30 people about how many siblings they have, then I would have 30 data items that I would somehow put on my graph. But but here's where it becomes maybe not the best choice. Let's look at this example. If you and a friend each survey classmates about their favorite food standing at different entrances to the school, you would each graph your individual data using the values that you collected. Sure. It's likely, though, that you would not get the same results or that you wouldn't survey the same number of people. If one of you is standing outside the bus, the door where the students who come off the bus enter, there's a lot more students who ride the bus to school than maybe students who come by car. And if that's where you're standing, you won't collect as much data. Not bad, it's just because of your particular location. But in an effort to be fair to all students, you choose to stand in those two different locations. The problem with this is because one of you may have surveyed fewer students, it's going to look like the data is way off for that person. Even though maybe overall most students would say pizza is their favorite food, it might not show that if the graph of your friend who maybe didn't collect as much data bar would be lower for pizza. So in an effort to make this more fair, we use something called a relative frequency display. And a relative frequency display measures frequency based on the fraction or percent of the whole that falls into the category. So, for example, if you surveyed 50 classmates and your friend only surveyed 20 classmates, it's possible that your friend's results would look much less convincing compared to yours based on the fact that more students entered through your door. So although you might not get the same results, using a fraction or percentages would give a more fair display of the data. If you each had 50% of the people you asked say they liked pizza, your graphs would look the same, very similar then, making it more convincing across the board that yes, we should have pizza at the next party in the middle. So how does this relate to the matter of opinion activity that you're working on right now? Well, here we have the graphs for Letitia and Julio. And this first graph here is just a frequency graph. It's showing how many people said yes to Hornets or no to yes to Panthers, or that they don't care. So looking at that graph and knowing that Julio appears to have, well, definitely surveyed more people. So it looks more convincing in one way than the other versus this relative frequency graph where we had taken the percentages of the people who said yes to Hornets and the percentages of the surveyed who said no to Panthers. Looking at this, it doesn't look like there's that much of a difference in the data that was collected versus up here when I'm looking at this, just strictly looking at the raw data and the numbers. So in some situations, it might be better to use a relative frequency graph versus a raw frequency graph. Okay, we're done with this video. There's no WSQ. Just wanted to give you that little bit of extra information as you proceed in this quadrant and on this activity so that you can better answer these questions. Please, please come see me if you have any questions.